Alright, today we are going to test this amplifier, this LNA I got off the Zons. It is a, let me get that in focus there, TQP3M9037-LNA, Tango Quebec Papa 3 Mike 9037 Lima November Alpha. It is a RF amplifier. There's the frequency range and the impedance. It comes in this nice little enclosure. The inside is just a bare board. There's no tin or shielding on the board itself, so this is the only shielding you get with this one. Let's go ahead and fire up our signal generator and tracker. Give that a second to go through its boot sequence. We're going to be using a RIGOL DSA 815 Delta Sierra Alpha 815 spectrum analyzer. Alright, so the equipment we're going to use for this test are our device under test, our LNA, our tracking generator. We need an output cable and an input cable with SMA connectors on it. So this is just a end-to-end jumper with an SMA cable, or SMA plug, or male plug if you will. On one end there's a pin right there, and then on the other side same deal, same connector on this side. So the first thing we want to do is normalize this cable. We want to reduce any noise or attenuation that this cable might introduce to our device under test, so that we're purely looking at the properties of the device, not the properties of this cable or the environment or the lab or anything like that. So we're going to go into our tracking generator, the TG button here. I'm going to hit that. We're going to turn on our tracking generator right here. And then we're going to come down to normalize. I haven't changed any other settings. You saw the machine, it booted up. I haven't touched anything else, okay? Come down to normalize. And then what we want to do is we want to take this barrel connector. This is going to let us connect one cable to the other. So it's just a jack or a female to female or jack to jack connector there. And we're going to put that on each end of our cable. So first I'm going to take the input cable. I'm going to put that there and make sure you screw your plug, not your jack. So hold on to the plug, screw the jack. Supposedly this makes the threads last longer. And then same deal with the other side. We're going to take our plug, put it onto our jack, hold it in the middle here, and tighten. And you'll notice when I did that, we got a signal up here, right? So that's the power that the device is putting back into itself. We just read that here, right? So we want to come over here and hit normalize. And what it's going to do is it's going to deduct the power that it's sending out from the power that it's receiving, so that the only thing that should be introduced on this line here is anything that happens in between. Currently nothing, right? We're just straight through, just a pass through. So there's nothing happening, so we're getting pure power all the way through. Let's change our reference level just because it's all the way here on top. Let's bring it down so it's more reasonable. So we're going to bring it on down to about 60, right? So that's just so we can see it here on the screen. Cool. Let's go back to our tracking generator, and now we can put our device under test in line. So we're going to disconnect the barrel adapter, unscrew that, screw the other side, put that aside. In some instances you might want to use an attenuator. I have a little mini circuits, 10 dB, make sure you can see that there, 10 dB attenuator. Right. So I would want to use this if the input to my tracking generator doesn't accept the amount of power I'm anticipating. If I don't know the properties of the device I'm testing, it's a good idea to use this to protect your equipment, but we're going to play with fire today. We're not going to use that today. We're just going to use our device under test. So we're going to take our device. First thing we want to do is hook up our RF output. So we're going to hook the RF output of our amplifier into the RF input of our tracking generator. Cool, cool. Alright, and then we're going to take the RF input from our amplifier and plug it into the generator output from our tracking generator. And we're off. We're not powered on, we're off right now, okay? So plug that in. So you'll notice the noise floor has changed. We got a whole bunch of ripples in here. Very noisy looking ripples. So let's do this. Before we go any further, let's save this so we know what the noise floor looks like. So we're going to, let me show you the procedure I went through here. I went to trace. I selected the first trace. It was automatically selected. And then where it says trace type here, I'm going to hit that button and I'm going to change it to freeze. And what that's going to do is that's going to freeze that first line there, right? The first reading we had from just the device in line, right? So we haven't done anything. It's not powered on. It's not receiving power. All we're doing is pumping power on one end, going through whatever bypass circuitry is in here, and passing it out the other end to the input. So let's freeze that so we know what that looks like, okay? So now also let's go in here and let's enable the second trace. And we're going to set that to clear right. And what that's going to do is that's going to continuously update that trace. And you'll see we haven't changed anything. We just now have two traces. Little solo jazz business going on down there, right? So we got our frozen trace and our active trace. So we need to apply power to our amplifier. So we're just using regular USB 5-volt power just off of a wall wart over here. And we're going to plug that into our amplifier. Again, we shouldn't see any change. The amplifier is not on. Okay, no real change there. So let's see what happens when we fire up the amplifier. Ooh, look at that. So now we have power. Now we have power going in. You'll see this level jumped up here. Right, so we do have some amplification. We started at a baseline of 0. When we put the device in line, we get some attenuation and we get some noise. But with the amplifier in line and on, look at this. We have a nice trace right here. There is a dip right here. And let's use our marker to figure out what that dip is. That dip is around 715-ish megahertz. It's unclear what our 680. Yeah. So we'll have to look at the specifications for this amplifier and see if that's to be expected, right? And you'll see there's some ripples in the amplification down here, but there's a solid plateau between about, let's say 680 here. And if we roll all the way back to, right in the middle of the amateur radio band. Well, too bad for us hams. We don't get maximum amplification in the amateur radio band. It could be that there's some filtering built in. And then on back down, we have nice 26 dB there, 26 dB, and then it drops down. And the low end, the maximum this thing will go to is about 1.5 gigs. So let's say on the high end, we still get about 18 dB of gain on the high end. So one other thing we'll do is let's select a nice frequency here. Let's go to the 70 centimeter band. 70 centimeter-ish, sure. High end of the 70 centimeter band, right in the middle. Okay, so you see it about there, we get about 25 dB. See it's jumping around a little bit. Let's zoom in, if our hero can remember how to do that. And span, zoom in, go left a little bit, zoom out. And then frequency, center frequency, let's move it back to 460 something, okay? And span, zoom in, frequency. Yeah, okay. Span, there's span. Alright, let's look at a 2 megahertz span right here, okay? So we're looking at a span of 2 megahertz and a frequency of 446.0 megahertz. Okay. Alright. No, that's not what we want. Our span is 2 megahertz. Our frequency is 446.0 megahertz. Alright. Now I want to go that direction because you can't. It's all the way off there to the side. So span. Zoom out. Frequency. Okay, let's roll with that. So you see we're at about a frequency of 446 megahertz, 446 megahertz, so 70 centimeter handband-ish. We've got our amplifier on. If I hold it, doesn't really change it all that much. I'm getting about 26 dBm, or just 26 dB of gain, and we could verify that if we switch off our amplifier. Look at that, nothing. Switch back on, some nice gain right there. So, I'm not sure if that's a reasonable amount of noise to be expecting there. A couple of dB of noise. Touching it doesn't really seem to change it all that much. So, there you go. We've tested our amplifier. It works. It gives us nice amplification. If we zoom back out, we go to span. Come on, friend. Span. Full span. Zoom all the way back out. Alright. Center frequency is 750. So that's what our amplification looks like with this. We'll compare it to the spec sheet and see what it says, but we've now tested our LNA. So to repeat the steps we went through, we fired up the tracking generator. We normalized our cables with a straight through barrel connector. We tested the device without power applied, and we tested the device with power applied. And then we zoomed in on a couple of frequencies just to verify what the amplification looks like on those frequencies. And it looks like we get about 25 dB of amplification, at least across the bandwidth that this spectrum analyzer tracking generator supports. For the interested, I'm going to switch off the amplifier, and let's verify that this attenuator works. So we knew we were getting about 25 before. This should take about 10 out of it. So let's see. See if there's truth in advertising. We should probably test this thing separately, but let's say we tested it before. We trust it. It comes from a reputable source. Okay. And let's switch back on. Look at that. So now we're getting about, hey, look at that, 15 dB. It's almost like this took exactly 10 out of it. Pretty cool. Okay. Let's test our math skills here, okay? So we're going to go back from 10 dB, and look at that. What do we got on the bench here? We got a 6 dB. Let's see if the 6 dB works. Remember, we're getting about 25 before. So how about all the fourth graders out there tell me what we're about to get? If we had 25 and we're about to take out 6, what do you think we should get? Let's see. Hey, look at that. 19. I like that. Looks good. So our 6 dB attenuator looks like it works. Switch that back off. And then, for our final act, I'm going to test the attenuator in line. Trying to avoid going all electro boom on my stuff here. Oh, I did the thing that you're not supposed to do. Whatever. So we're getting about negative 6 dB gain there. Or 6 dB loss, I guess you could say. So if we swap that out for a 10 dB. And that. Okay. And that. 9, 10-ish, thereabouts. Cool. Good enough for what we're trying to do here. Trying to win a Nobel Prize off of screwing around with some LNAs here. Leave that to Jodie Foster. There you have it.